We're a huggy bunch of folks at Ops Code, and I just had to do that to John. Unfortunately, it didn't make him as uncomfortable as I hoped it would.
I don't know that.
He's crying right now. The other thing that Chris Brown's going to be known for, of course, is smacking Rihanna. So if you go search for me, you're going to find the other guy. I had the name first. I'm just going to take a few minutes to talk to you all. Wow, these lights are bright. About moving DevOps, this movement that we all talk about today, from the gains that we've had, from where it is today, forward to something that I think is a true science. And I'm going to talk about why I think that's necessary. So real quick, it's always great to be at Velocity. Velocity has been a coming out party for our company since the beginning. This was us, I guess it was last year in the US. Every year we come to Velocity, we announce something new, the brand new company, and now I'm here actually announcing the opening of our operations in Europe. So always something new, and we've grown up with the conference. Before I was at Ops Code, I was actually director of engineering at Microsoft for a while, working in online services. Our goal at this was actually geographically distributed compute and content delivery to tier 1 internet users, 30 milliseconds or less around the world. So think about it as geographically distributed little things that looked a lot like EC2. And then, yeah, before that, I was actually one of the creators of EC2. And this was us opening the office in Cape Town, South Africa back in 2005, I guess it was. And there's a huge story to be told about all of that. Anyway, so enough about me. Always the survey. What about you? So how many of you folks out there would say your primary job is as a developer? That's pretty good. How many systems administrators? OK, interesting. How many of you are business people? It's a trick question. Turns out everybody is a business person at the end of it. You're all responsible for the delivery of your site or delivery of the service, right? You are actually the bottom line of the business. I'm going to get into that. How many of you identify with DevOps? I'm surprised. I thought it would actually be more hands. Well, all right. So I'm going to describe really quickly, before I get into it, the business universe and where ops is in relation to the CEO. And I assume you've all seen this. So you're over here, and quite often the CEO is somewhere else completely, right? Here's how the CEO talks to everybody else in the company. He talks to the sales guys. He says, you guys are the best. He tells them this because they drive the top line. They're the ones that actually sell the product, right? Then he talks to the product guys. He's always one-on-one, right? You guys are the best. Why are the product guys the best? So the developers out there, how many of you are the product guys or gals? Yeah, it's funny. It's getting a little sheepish now. It's like, I'm not sure I want to be the one. But you got the muscles, hey. Product guys are the best. Why are they the best? They build the thing we sell, right? And typically those are the software engineers. And this has been the classic tension for years between the product folks and the operations folks. Because then CEO turns around and says, hey, ops guys, do I have to fire you? The site's down again. And then you go home. Then you get this, right? When I was doing the research for this talk, I talked to lots of folks who grew up in classic operations, and no kidding, I talked to 2 guys who work for me at my company today who said, my last operations job, I was actually hired to roll back code. We would do a deployment, and it would fail, and the boss says, I don't know, can you roll it back? You can't roll back a burning building, right? This is not the way it's supposed to work. And DevOps is supposed to fix that, right? So how many folks think that DevOps actually has started to fix this problem? Yeah. I don't mean that to be a trick question. I actually agree with you. I think it is. I want to talk about how it's fixing it, where we're moving to, and then suggestions. Originally, when I was writing this talk, I felt like I was the loyal opposition, right? I'm a software engineer. I'm a product guy from way back. And I've got some suggestions for where I think operations needs to go to sort of, take that next step. So first of all, we've seen this. The whole reason that we're here, this is history. Business is changing dramatically. It's changing rapidly all the time, right? The effects of globalization. If you look at the physical effects, think about shipping, right? These are old numbers. 70% of seaborne trade by value in 2008, container ships. They haven't been around all that long. This is physical matter. You've seen the size of these ships that go around the world all the time. And then look at this. Again, old numbers, but 800 million internet users in 2005. And it didn't take us very long to get there at all. And ops makes all of that possible, right? There's product, sure, but who are the folks that are up 24 hours a day making sure the house doesn't burn down? This is an amazing movement in a very compressed piece of time. And it's interesting that many other disciplines, physical disciplines, engineering disciplines, have had the benefit of a much greater time span to bring their craft forward. And that's the thing I want to talk about. But first of all, take away this point. Ops is in fact winning. Ops is the bottom line of the business. 95% of the people in the Western world own cell phones. There's roughly 1 cell phone for every 2 people on the planet now, right? 42% are smartphones. These numbers are probably a little old as well. You've seen everyone talking already today about the importance of mobile experience and crafting for mobile, as important, maybe more important than the desktop experience in many cases. And in this connected world, software is the interface. It's everywhere, right? It's even in your car. You folks know where this comes from? The Prius, there we go. See, it's that recognizable already. Happened first with books, moved to all of the facets of retail shopping, and it's not just shopping. How many of you can do health records related things online now? Very secure. Insurance policies, everything, the mundane. Bank statements, everything is online, right? And where did it start? I think it's kind of funny that this has been a short historical trip, and when I was doing the research, I ran across a talk that John and Paul did at Velocity not all that long ago. I guess in our compressed time span, this is a lifetime ago, right? And then I found this quote, and this is the first important point I want to make. We should not let learnings from other fields, regardless of what fields those are, go to waste. There are decades of thinking and exploration there. And that's part of what I want folks to take away today, is that I think the next thing that needs to happen in operations is that we need to benefit from what everyone else has learned, that we need to start borrowing from all of the other disciplines and pull ourselves up by the bootstraps. And there will be lots of references to books in here. Personal recent favorite, Atul Gawande's Checklist Manifesto. There we go. I figured that one would be good here because as ops people, we're always making checklists, right? Everything succeeds or fails by whether or not you've checked them all off on the list. And it turns out there are at least 2 of us in the room that have read the book. So I feel better now. And just as an aside, I ran across this. I thought it was rather telling. This is from an article about healthcare in the US, but look at the highlighted portions. Incentives that generate terrible results, emphasizing treatment over prevention, and that favor complexity. And I thought, wow, that sounds a lot like software development. And that's actually what happens to us at the divide between software development and operations. You build a thing under strange incentives and you throw it over the wall, you favor complexity, and then you wait until the house burns down. And you wonder what went wrong. This is the thing that we are all trying to change. And I wanted to make sure this wasn't seen as a negative example. This movement that we're talking about, DevOps, is not a crutch, right? This is the thing that's brought us this far, but we can't stop here. It's actually a step forward. So what is the road ahead? By the way, I didn't realize it until afterwards. Does anybody recognize those, besides the fact that they're penguins? They're African jackass penguins. And I thought it was kind of funny that I was up here talking, and yeah. So here's the loop. Here's the progression. It turns out that almost every discipline that's worthwhile in the world goes through a series of steps, from a craft, from bespoke, handmade, one-off, highly polished, and it expands to a trade, where there are a number of folks. There's an apprenticeship, there are some best practices involved, but in some sense it's still lore, right? That, I would contend, is where we as a body are today. And then the next step up from that is to an established science, that there is a form of recognition that we all get when we take the next step. And so in the past few years, if you've said, well, my boss doesn't seem to favor operations in the way that he does the product guys or the research guys, I contend that we can get there, and that this is a natural progression, and it's just a matter of time. And then it becomes a cycle. That science, that theory, then feeds back into the rest of the craft. And it's happening with all the other disciplines. So if you look at electrical engineering, it's surprising how much we as a community benefit from it, maybe not even noticing. They went through the same thing from Ben Franklin standing in the rain with a key and a kite, waiting for the lightning to hit. And then suddenly we were breadboarding things together. And then at the top of that, you've got folks, theoretical or applied physicists, who've now built a theory. Electrical engineering, at the end of the day, is basically just about applying math to building stuff, right? Greatest example, Claude Shannon. Claude Shannon's a guy who started out doing physical engineering, wrote down some math, and suddenly we have information theory. We wouldn't have the bit without Claude Shannon. And then computer science is the same thing. When we talk about the software engineers, the folks who get recognition and credit today, they've gone through the same stages. Started out with programmers, started out with a field of secretaries at one point moving switches on a large panel wall, to then having programmers and a fairly established trade, right? So we go from hand-built, one-off sorts of things to having a trade with some best practices, and then finally a science behind it, and you get guys like John McCarthy. To me, he still looks like Colonel Sanders from KFC, but he's also one of my personal heroes. So, and it's worth noticing that even there, great quote, impossible that computers themselves could actually be a scientific field of study. So it's only been since the 50s, really, late 50s, that we started giving out degrees in computer science and trying to figure out from a theoretical basis what that means and from an engineering basis how it applies, right? So you're looking at these time periods again and figuring out how long it takes, who gets the credit, where the body of theory is. So where are we as a culture? Well, obviously, places like this, we're getting together, we have a trade, we're making history, we're driving the internet. We've had our hackers, our systems administrators, we've built things on the back of Unix for so long, and it's all running in the field. But I think there's one step that's missing still, and there's a formal recognition that goes along with that. One last thing about that, engineering is a confusing thing. At least in the US, for physical engineering disciplines, you have to take a test and be licensed to call yourself an engineer, right? It's been this way for quite a long time. My background was in electrical engineering. I was told when I got out of school, I had to do engineer in training, basically apprenticeship, pass an exam, and then pass the PE exam, practicing engineer. And up until that point, I couldn't call myself an engineer. So we in IT we've co-opted the term. We've been calling ourselves engineers since the 60s, but I bet you no two people can say the same thing about what that means, right? We don't have any sort of license or a thing that you can point at and say, this is in fact the discipline. And I thought I was being really original when I figured all of this out, that this is something that I came up with. Turns out, Steve McConnell wrote about this. So if you take a look at the book, After the Gold Rush, it's an analysis of what happened to software engineering and this exact progression. And he wrote this in 1999. So if you remember a moment ago, I mentioned John and Paul talking in 2009, and you see where the software engineers were getting their recognition in 1999. We're not that far behind, right? But it took software engineers nearly 40 years to get there. That's a great quote. In the long term, software engineering practice needs to be elevated, right? So I think we've reached the point where that's the case. In the long term, operations as a science also needs to be elevated. Again, 1999, 1950s, 1999, 2009. So we are just now entering that era. So how do we build this discipline? Well, there are some struggles, right? 800 million internet users. Look at the spread of everything that we've done. Technology is changing faster than you can print a book about it, or at least a good book. You look at the hundreds of books that are out there, it's hard to find something that's pertinent today, or you have to wade through things that are very pointed about a particular piece of technology. And so universities have been reluctant to actually create a degree course around this, because how can you? Can you create a degree course around JavaScript when next year everybody's going to say, I'm learning Lua now, and you can throw all the books away? It's tough, right? I thought this was great as well. It's exactly that. Ari Pinar, another one of the voices in the DevOps community, trying to find books on good systems administration practices. These books, again, are either broad and not applicable, or perhaps deep and not directly applicable. I actually disagree with the deep part. I think that's the thing we need to fix as a set of folks, right? And turning a new engineer into an ops expert takes 10 to 15 years. That sounds an awful lot like an apprenticeship, doesn't it? So we are a trade, we are a craft moving to a trade, and from a trade moving to a science. And we're on the way. We've actually got books now that are applicable. You can point at something and say, this is about systems administration, or in this case, so we've got John's book on capacity planning, Neil's book. I don't know, how many of you, anybody here read Neil's book besides John? Oh, hey, there we go, people in the back. That book looks a lot like a math book. I'm going to mention that too. And then Mark Burgess's book on network and systems administration. If you had to pick a guy, I would say that Mark is the first guy that I would say is a scientist in our field. And when I talk about borrowing from other disciplines, Mark's got advanced degrees in physics. This is how it always gets started. You borrow from other disciplines, you bring the skill along, and in this case, there's a whole lot of math and science in what we do. Wanted to touch on this one really briefly. The notion of first principles analysis versus what we call phenomenology. I'm just going to admit it. What I see a lot in operations today is I solved this problem this way because I saw it solved this other way yesterday or a year ago. Phenomenology, the idea is it's about the appearance of a thing. Here's how the problem looked the last time I solved it. I'm going to apply the same template without doing first principles analysis. Step back for a moment and figure out what actually goes into the problem. Here's why you need to do that. This landscape is changing. The scale is changing so rapidly that the way you solved a problem yesterday might not even be applicable tomorrow. If you had 10 machines or 100, and now you're deploying to 1,000, I bet you that's nonlinear in terms of the complexity, right? So if you were drawing a straight line, you're probably wrong. Step back, look at first principles, and here you go. The debate is over about this, right? I know software engineers do it too. I don't need to know math in my job. And I'm not telling you need to know calculus. I'm not telling you need to know lambda calculus, although that tattoo, I'm totally getting that. I'm a big fan. Actually, I'm too chicken to get it, so I put it on every talk. What you do need to know, though, is just simple modeling. As systems administrator, so another thing, how many of you out there are responsible for capacity planning in your organization? So I bet you've got a nose full of Excel or something like it all the time, right? You're building models. It's math, it's not horribly complex, but it's a fundamental skill to what we do. And you can move from there along a spectrum to things like modeling in R and RStudio. Super cool, super advanced. And you're already doing all of this, right? So if I asked you, how good is an average of something? Do you look at the averages? TP90, TP99. This is the thing when I was at Amazon, every week we had metrics drill, and there would be a deck, and whatever your service was, somebody would go through and ask you about your TP95 and TP99, and we lived and died on metrics. And other disciplines do it too. Now, this for an electrical engineer, this is first year of study. Characteristic curve of bipolar junction transistor. I apply a voltage, I expect a current draw. I bet you do something a lot like that for the services that you run. And we were talking about synthetic testing a few minutes ago, right? I apply so many requests to something, I have so many responders behind the scene. Here's what my pipeline of interconnected services look behind it. And from that, if you're really savvy and responsible, you're building a model of reaction. Well, what happens if I add more front-end boxes? Well, what happens if I add more database slaves, right? So you're building this sort of characteristic model for future capacity planning. Another one to borrow, systems theory, and for the same reason. Everything we do today in a connected world is a distributed system. Learn about things like throttling and back pressure and staged pipelines and what to do under degraded performance. I bet as a part of capacity planning you think about this, but I bet quite often it doesn't go back from your thinking into the design of the product. This is where DevOps really shines, because you can get together with the guys building the product and say, if I could only build probes in right here that I could monitor, and I could tell you how each stage of the flow is going and where you need to add capacity. So the guy who's got the model and the guy who's building the service can work together to characterize it. Really quickly, we also need to get better at writing things out a little longer than a blog entry. Some blogs are super great knowledge, not necessarily great for long-term repository of knowledge or for peer review. That's another thing that we can borrow from some of the other disciplines. Sightseer, great place to go for academic papers. You can take these papers, read them, turn them around, and build them into practice. That's really important. This isn't just a place where academic papers go to die, right? And archive.org, same thing, not just computer science, mathematics, physics. Beg, borrow, and steal these techniques from everyone else out there. We've already shown that things like systems theory, characteristic curves apply equally to what we do as they do to everything else. This is my last point. We are a community. We're all here so that we can get together and talk about these techniques. As these guys were saying, the hallway track, it's 50% of the value, just being here. So as a community, we need to behave. We need to be better to each other, and we need to expect others in the community to behave responsibly. Is Twitter, something like Twitter, it's a horrible medium for real communication. The only thing that you can do in 140 characters is tear somebody down, right? This is an example of a real tweet from last week. Took the names off to protect the innocent, but come on. If you can have somebody out in the world working his heart out for 20 years, and that's the best thing you can say about them, we as a community are failing. We celebrate the smart bastards, the bastard operator from hell, right? This is us. We think it's funny, and we do it all the time. Turns out that undermines our entire industry, right? Makes us inefficient, makes us unwilling to work with others. I can tell you, I read Twitter, I read those feeds. That's the list of people I'm not going to hire. It's really easy to separate the good from the bad. At OpsCode, we have a very serious no asshole rule. We make it a part of our interviewing process. By the way, another book on the list, the no asshole rule. Very, very good. I can say that because it was printed in the Harvard Business Review. So what do? So be nice. If you're not the expert on something, lead with a question rather than making a statement. Ask somebody why they designed for a particular thing. And maybe you are the expert, and you can give them a new technique. But lay back a little. Lay off the snark, and recognize the fact that they've put a lot of time and effort into it. Because I guarantee you the wheel spins, and you're going to be the guy who gets the snark at some point or needs the advice from somebody else, right? So one last thing I want to leave you with. Everybody's seen this quote, right? I think we've talked about the fight between software engineers and operations, or between the operations guys and the rest of the business. The fighting's over. I think we're at the stage where you win, right? That's it. Thank you.